Hit. Alrighty. Let's see how this works. Is there a way that I can pull up chat somehow? View, docs, sneeze, control, toolbars. Where did it go? I had it pulled up just a second ago. Where did chat go? Where did chat go? Stats. Oh, this is cool. Wait, where did... Docs. Reset docs. Yes. Chat. Ah, perfect. Okay. Chat has been pulled up. What joy. I'm just gonna resize that. Maybe do this. Yes. Alright. Cool. Let me turn on the lights so I'm not just blue. Alrighty. Oh joy. Alright, let's update Altium. Alrighty. What's going on, Aiden? Okay, so let's try to get the Altium workspace settled, because there's a lot of things going on right now. Close, license management, close all of this stuff, close this as well. DC you can, oh, PyBoard's gonna be really annoying. Well, I'll worry about that later. Close all documents. Now what I want to do is go to my personal workspace. And then let's hide this. I want to create a new project, and the goal for today is to get started with the schematic for a split keyboard PCB. So the thing is, I want the split potentially just doing one half at a time right now. I want the split to use ESP32 modules because I have those on hand. And the goal of this project is just to basically get some experience with more PCB design and also automated PCB assembly tools on JLC and PCBWay and stuff like that. And from there, to use a bunch of the parts that I have laying around when it comes to keyboards. So that's switches, keycaps, whatnot, because I just need PCBs themselves. So there's going to be a couple of layers to this. There's going to be the actual PCB design, which is going to be creating the library components and all that stuff, creating the schematic, and then creating the layout, as well as doing the actual layout of the board itself. So I'm probably going to tap into the keyboard layout editor to do that. And in addition to that, I need to design an enclosure for the actual keyboard when I make it. So all of that jazz. Version control, yes. Description. So let's call this split keyboard PCB for now. Description, mechanical keyboard PCB for two-handed split. Now, the other thing is I don't know if I wanted to go mechanical or if I want to go Hall effect. Because Hall effect would be really cool if I could pull it off. I think let's just go with let's go with Hall effect. Hall effect keyboard PCB for a two-handed split. Now, Hall effect is going to be really interesting because if I wanted to be two-handed split and also Hall effect, it's going to have to be wired. So maybe for now I'll just stick with mechanical, because the power draw of the Hall effect is quite large. So I'll leave that for a different project then. Let's do a default PCB project. Alright, so what's going on with our default PCB project? That looks weird. What I can do though is I am going to get started by making a component library. So I think what I need to do is to create components. Switches. I wonder if there's already a switch created though. Let's see. Manufacturer part search. Cherry MX. We do. Alright. Oh, that's a really ugly 3D model. I wonder if there's a better one. That the footprint is not present. So only these two have the actual footprint. Interesting. Let's see if I can find the footprint somewhere else online. Altium footprint for Cherry MX switches. I had them at one point. When did I have the actual thing created? Cherry MX switch breakout. Let's see. Where did I have the other PCB saved? Let's check my GitHub. Altium PCB files. I fear that this will not contain what I'm looking for, but it's worth a shot anyways. Yeah, this is just the actual PCB. So, maybe we should just start from scratch. Mitosis keyboard. Now the reason why I want to start out with the mitosis keyboard is actually because there's some really interesting design features that this thing has, including using its own... Oh, what? You can... Requested page couldn't be found? That's so sad. Including using the PCB itself as the plate, which is doable. And that does lessen the manufacturing costs, albeit just by a little bit. The thing is if this becomes too big of a pain to actually do, I might just do away with this whole strategy. Because 3D printing a plate is actually just not a huge deal at all. So let's see if there's PCB manufacturing files and design files. So that's the manufacturing files. This is the design files. Mitosis, PCB doc, PCB lib. Ah, perfect. Wonderful. Let's download the raw file for this. Save. And for now, let's also add the Cherry MX switches in here too. Now, the interesting thing about the cherries is that there's these two separate ones. Why are they separate? So this is a Cherry MX Black. This is also Cherry MX Black. And N and W. Is there really a difference? I don't think so. Although, the more I can edit the 3D model, the better. So what I'm going to do is I'm actually just going to save this into switches. Okay. And I want to use all of this stuff, actuator length, all of that. But I also want to not use the 3D model. Let's see if I can edit the 3D. Alright, man, I forget how to do all this. Zooming in and out. Okay, cool. I think the controls are a bit different from what I had on my other computer. It looks like a block. That's huge. We do not want it to look like a block. Instead, we want to actually put in the correct switch for this. The other thing is I also want to see if I can add some more silk screen to make it clearer, because that would help a lot actually, instead of having to do it manually. So let's see how I can do that. Cherry MX switch 3D model. Let's see here. Until I get a job and it's ex-AMD GOAT. Yeah. We'll see if I can get a job. I'm gonna reach out to AMD probably tomorrow or Tuesday and just ask them if they have any updates about my return offer. Because it is pretty rough. It's pretty rough out here. And if they don't, then I'll just ask if they can, what's it called? Recommend me, like give me a heavy recommendation for another team. I mean, to be fair, this is a little bit of a struggle. We'll see. I got a referral for SIG hardware, and that'd be really nice because then that gives me a way to get back to Chicago. with like FPGA engineering and stuff, but so it goes. I think I'll probably eventually find something at some point, so I'm not too worried. But this is also just a way of keeping me like grounded, you know, stream every day. How is the stream quality, by the way? Is there anything like scuffed about it? Box, YouTube live control panel. Cam is a bit funny. My mic is very good. That's nice. Why is the cam a bit funny? Oh, I see why. It's doing the thing. Yeah. It's because I don't want to show my background because it's really scuffed. That's true, that's true. You were there when the ancient texts were written. But you know how it is. You always like start a project, especially when you're me. You always start a project and then never end up finishing it. So hopefully through this I can finish up a bunch of my projects because I do have a whole list of them. Just like, hold on, let me pull it up. Oh my goodness, there's so many. Most of them are either related to solar, just like personal keyboard projects, research, mini GPU, FPGA stuff. Maybe I should stick it in like the... Nah, that's too much. Oh, I can pin it. Yeah, I'll do it later. I won't show my entire hand because there's a lot to work on. But yeah, mini GPU. Mini GPU. The GPU is going to require me to do a lot more digging and understanding how GPU architecture works, because CPU architecture is relatively simple, I think. Well, it's simple when you've taken 2 classes on it over the course of 6 months. But for GPUs, it's like I don't have the same sort of experience, and it looks like the architecture itself is quite different. Obviously, there's some things that are relatively the same, like cache management and all that stuff, but probably still enough that I need to actually dedicate some time to it. The ISA is also interesting. The, what's it called? Because I think we want to use like a custom ISA basically. That's why I was like questioning like, oh, do we want to just use like RISC-V vector instructions as an ISA? But not too sure. Save. So I think what I can do over here is go back here and then place 3D component, not extruded, wait. Yeah, not extruded, 3D body, there we go. This PC, actually no, home, downloads, switch.step. Oh, why is it so large? Okay, well, let's see if this is what we expect. Oh, that's why. Okay, I have to rotate this guy. Properties, rotation, that's the wrong way. There we go, that's the right way. And then we have to shift this up. Standoff height. Oh god, this is so scuffed. We're gonna do 4.8. That looks about right. Yeah, that looks about right. The pins are not in the right place though. Why is this? This is because I need to move it. We're gonna select this, move this down. There we go. Go back. They're still just a little bit off. Go back here. I think it might be because, yeah, it needs to be halfway. There we go. That looks nice. Basically flush. Oops. It's off by just a little bit, and I'm not quite sure why. What is... How large is this thing? Switch, mechanical one. Maybe I should find a better model. I'm not sure why this model extends out a little bit. Is there a particular reason? That's just the tabs doing that? I think it is. But it shouldn't. Let me measure this. Snap grid is being annoying. This should be in millimeters. There we go, 15.64, that makes very little sense. What are the dimensions of a switch? MX switch dimensions. Standard are 14 by 14 for the plate cutout. I'm gonna be right back. My cat is doing things. Swag! We got the kitty on the desk. Real Cole gameplay. Hi, Cole. Dude, have you applied to Adobe yet? You guys are getting the Cole ASMR. Yeah, you should check out Adobe. I feel like they pay pretty well.
my cat? What is my cat doing?
Oh, he's on top of my PC now. Alright, swag. Let's find a better switch footprint, but at the same time, maybe I can just move this thing now that I have it. Guys, what is going on? Range of 20.91, 322.0. All right, this looks good now. Okay, so we got the basic switch footprint. I think what I need to do is save this to the server, but then at the same time I need to upload the actual 3D model onto the server as well. How do I do that? Altium. Save to server. Well, let's just try this. So first of all, let me rename this. Cherry. Next switch. Template switches. Part choices. I'm just gonna get rid of that because I don't want it to factor into the cost of the board. I mean, low-key, I think it is just better to get a job if you can. Like, my take has just been apply everywhere and then try your hardest in every interview and see what doors open, you know? Because, like, you never know. Maybe the problems and stuff that they encounter on the day-to-day are just different from what you have experienced in the past. And I don't think in the current job market we can be pick and choose. Beggars can't be choosers. At least that's my take. Release notes, first revision. Cole is yowling in the background. Yeah, no, that's fair. Like, you can just put software engineer. Yeah, exactly. So. Is there a way that I can see in Explorer? Cole has the zoomies right now. Components, switches, Cherry MX. No, I don't want to add component. Create other item type. 3D model. Name. Cherry MX switch. 3D body of Cherry MX switch. Okay. Let's see if this is what I want. I don't think that was what I wanted. What is going on? Mechatronic 3D models? Oh, shoot. Oh, I can upload. Banger. Switch desktop, release notes. Cherry MX Switch. Okay. Where did this end up? Where did this end up? Hmm. Okay, well, I'm just not going to worry about it too much. Compilers are super important in low latency stuff. Not everyone can spend their entire day looking at Compiler Explorer and checking the outputs. Sometimes you just gotta hire people to do that for you. I know HRT has a compiler role for, I think, even UGrad. Yeah. You know what I want to do? I want to code a little script that takes the Polybridge soundtrack, but then like plays it as if it was like Minecraft. So just like randomly you'll get one of the songs playing out of the blue after like an arbitrary period of time. So it's not like constantly playing music, just like fades in and out sometimes. I feel like that'd be a pretty cool thing to do. Alright, let's see if I can find the ESP32 W room 32E. I think this is the one. Yeah, with the little PCB. Is this the one? Because there's also the D. Which one? Eight megabytes. Which one is the one that I have? I think it's the E. Yeah, I'm just gonna go with the E. We're gonna save this to my little microcontroller. Do I have a microcontroller? Capacitors, connectors, integrated circuits, logic drivers, amplifiers, processors. We're gonna use all of the parameters. Okay. And then we are going to put this why are 17, 18, 19, all of those no connection? I feel like those should be... Huh. That's odd. And then IO 1 and 3 are the RxD and TXD. That's fine. Okay. Sensor VP, sensor VN. What are these pins? I gotta look at the datasheet. Okay, but for now we can save this to server, I think. Component duplicator designator. Yeah, it's fine. Can I wave all of these? Hi, Ishan. Alright, so let's look at the datasheet at the 32E. Because I'm pretty sure... I'm not sure why there is a difference. Pin layout. Yeah, why are these no connections? I do remember these having actual connections. See note 1 under the table. Are connected to the SPI flash integrated on the module or are not let out. Oh, okay. Gotcha. Okay, fair enough. What is sensor VP in VN though? GPIO 36. RTC GPIO 0. ADC 1 channel 0. ADC 1 channel 3. Okay, so recommended operating conditions, VDD 3.3. That means if I want to use, I'll need, okay, so if I want to use USB power and, for example, like a coin cell or a rechargeable lithium ion cell, I'll need to have some sort of charger IC on board as well, which is going to be kind of a pain. Current consumption. Dang, this uses a ton of power. That is with 802.11b GN though. Does that also count for Bluetooth? Low energy? Does ESP32 have BLE? Yes, okay. BLE 802. It's 1.5, okay. Every time I mute my mic to tell Cole to stop scratching the freaking window, I feel like Hassan. I need to figure out what I do with the whole window situation. Cole just really likes to scratch the netting on there and it's already torn up. I'm gonna have to buy a replacement at some point before I move out. All goody. Okay, so this is a recommended schematic for JTAG and whatnot. I should probably implement this, but okay, I don't even know what sensor VP is supposed to be for though, because I don't remember this being anything. I'm pretty sure this is just GPIO. ADC inputs and can only be inputs. Gotcha. Okay, so input only pins in this case. Here's the ESP32. I want to figure out the power requirements, electrical characteristics. RF current consumption in active mode. I'm looking for receiving BLE. Transmit BLE, power at 0 dBm. 95 to 100 milliamps? Are you kidding me? Alright, how much is Nordic? NRF 52840. Actually, if I'm gonna implement this, I'll probably be using the 52833. Documentation. Resources, product specification, power clock management, power? Current consumption. Current consumption. Alright, sleep. System on, no RAM retention, wake on any event, 1.1 microamps. Okay, so radio transmitting / receiving is what I'm looking at. See, even with this, Bluetooth low energy mode, 8 dBm output power, 15.5 milliamps versus 130. It's almost a factor of 10. Like, that's actually insane. What the heck? Oh. Maybe I'm gonna have to go with the Nordic chip then, if I want this to be any semblance of... Alternatively, at the moment, I could just go for a wired PCB design if I want to make a keyboard. To be honest, I probably should just go for a Hall Effect wired keyboard anyways. I feel like that'd be a much more interesting project to work on. Alright, my 5 concurrent viewers. How do I make a poll? Start a poll. Split wireless keyboard or wired Hall Effect keyboard? Start poll. Alright, my 5 concurrent viewers, take your vote. What should I work on? Dude, they call me a streamer. You know, Aiden, maybe if things don't go to plan, we'll just become VTubers. Let's add that to the list of projects. Oh, I just lost a concurrent viewer. NT. Alright, we're at a 50-50 right now. This is pretty rough. Let's look up the SAM 4SC, because this is the other chip that I have. Do they have a QMK branch for Hall Effect support already? Hmm. I wonder if they have a branch of this somewhere. Mhm. Oh, huge. Keychron Q1HE. Okay, so they do have the firmware. Wait, that's so nice. Reddit.com/r/Formula One. Where'd you see that? Oh yeah, Formula One. League of Legos. LeBron announces his retirement. Alright. T1 versus 100 Thieves. That's gonna be an interesting match. Unfortunately, I don't think I'll be awake for it. I'll probably just work on this for a bit more, decide on what I want, architect it maybe a little bit with the block diagram, and then call it a day. Sam Forrest. Alright, but how does the actual HE firmware work? Oh, it isn't actually a real firmware, it's just a compiled binary, I think. Unless there's supposed to be a Keychron. What if I just don't use QMK? What if I just make my own custom firmware? That's true. Making my own is in the most in spirit of the stream. And it would be relatively simple, I think. Might just make my own. In that case, let's take a look at the peripherals of the Sam Forrest AP. Oh, my Sam Forrest AP 1269 page datasheet, my beloved. my fucking washing machine just broke. Well, I know who's going to Plex later. Stress fracture, the drum shattered? Oh. You're not responsible for paying for that, right? Call up your landlord. That's actually crazy though. Stress fracture. Yeah. That is unfortunate. F's in the chat for Aiden's washing machine. $16 of ROM. Low power modes. Okay, USB 2.0 device, 12 megabits per second. See oscillator. Two I2C, one SPI, one I2S, one high-speed multimedia card interface. SD card interface on a SAM Force AP. Pretty crazy. Two 3-channel 16-bit timer counters with capture waveframe compared to PWM mode. Quadrature decoder logic for stepper motors. PWM generation. I don't need any of that. There's actually so much on here. USARTs with RS485. UARTs. Okay, 16 channel 1 megasample per second ADC with differential input mode and programmable gain stage and auto calibration. Digital to analog converter. 1 2-channel 12-bit. (16-channel 1 megasample per second ADC). That's the one that I'm really looking at. Because the thing is if I want to do a haul of which absurdity of which statement? Sorry, I missed that chat. Oh, the washing machine, yeah. My washing machine just broke. Okay. Oh yes, my beloved 1,269 page datasheets without a proper page of table of contents. Hold on, let me yell at Cole. Aiden's Chungus washing machine. Alright, let's see if I can find the section. Whoa, 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 whoa. What is going on here? They just added the entire Cortex M4 instruction set. That's really funny. That is really funny, actually. Do 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 do. Something something PMC clock generator power management controller. Ah. Dude, where is the ADC? Where do they talk about the ADC? Oh, waves. What the hell? Timer counter? CSART. SD card. PWM. USB, this is useful. Oh, ADC. Here we go. Scrolling through all of this. Hi, Jojo. Alright, analog to digital converter. 16 is based on a 12-bit ADC managed by an ADC controller. Also integrates a 60-to-1 analog multiplexer, making possible the analog to digital conversion of 16 analog lines. The conversions extend from 0 volts to the voltage carried on the pin A to V ref. Conversion results are reported in a common register for all channels, as well as in a channel dedicated register. Last channel is internally connected by a temperature sensor. Allows automatic detection of values below a threshold, higher than a threshold, in a given range or outside the range. Oh, interesting. Okay. So there's a trigger, time capture channels. And then this goes to... RTC, wake up. Alright, cool. Because it'd be interesting if you could have a Hall effect switch. But then you'd have to have a 3.3V. Okay. You set an output, an analog output from the DAC that serves as the reference point for all of the switches. And that allows you to do your arbitrary But then the issue becomes okay. So let's make a Miro board. Block diagram it. Blank board. Alrighty, so what are we starting out with? So we want to make the keyboard. The idea is that we're going to use... Alright, so the vote has been decided for split wireless keyboard. I'm low-key debating whether or not to do a split wireless keyboard with the Atmel chip and then having an external Bluetooth companion chip. Bluetooth to SPI module. Or if I should just use the ESP32. ESP32. That would be really crazy. A crazy thought just came to mind. What if I made a solar harvesting keyboard with photodiodes? No, okay, because the thing is I had this idea originally because of solar. The idea was instead of using button cell batteries for the light board, if you could have the sun shine on your board with the photodiode, you could harvest energy from the sun instead of having to just use a button cell. And then a crazy idea came to me, which was for idle storage of the battery itself. If you had a microcontroller connected to each one of the battery's terminals, when the car is not on, you could still you could still get the voltage of the battery by harvesting energy through the photodiode, and then as soon as it gets enough energy to actually transmit something, it just wirelessly sends a packet to like a central controller that tells that controller what the voltage of the battery is. So no matter if the battery is actually on or off, you know whether or not it's in a state to be turned on. That was a crazy idea that I had. And then the point was, well, we're going to bury the battery into the back of the car with no light. So I was like, oh, shucks. But for a keyboard, assuming you're going to be using like your monitor, I wonder if there's enough energy in a photodiode harvesting situation to be able to power a keyboard reasonably for a given amount of time without relying on a battery or a USB. Low-key, that would be kind of insane. Because I wonder if you have multiple of these, how much it would... I don't think this is necessarily practical. Because I was thinking about it. The only way that you could get around something like this is like infrequent transmissions. Okay. All right. Then back to the drawing board. So for a wireless split keyboard, if I wanted to make my life easy, I think that the most efficient way to go about this is, so we actually have the keyboard matrix. Well, first and foremost, how many pins do we want? Because we could do 4-layer PCB. If we do 4-layer PCB, then we can go with the QFN layout. QFN 7, which exposes how many GPIO pins does this expose? Block diagram? No. Hardware and layout, pin assignments. For the QFN 73, digital I/O. So assuming this is 31 and that's the highest that they offer. So you should theoretically have enough to just direct connect every single switch onto the actual microcontroller itself, which would be very, very nice. I wonder if you could do the same for the QFN 40. 0001 So this just goes up to 31. So the question is if 32 pins is enough, assuming that you even have 32 pins, because it doesn't look like you do. Well, how many general purpose I/O are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. 42 would mean a 6x7 matrix, which is, yeah, more than enough for a split keyboard. So low key, I think the easiest way to do this is just have all of the switches just direct connected to the actual MCU. And that's assuming that we run with a Nordic. So this is going to be the Nordic system. If we use a Nordic MCU for this. And then the MCU itself would have to have some sort of charge input. So this is DC plus, and this would come from a power management IC. And then this power management IC then would connect to also a battery. And this power management IC would also connect to USB for charging. And then the USB would also go over and connect to the MCU. Now the other thing that this would output is Bluetooth Low Energy along some sort of antenna line. And then maybe 2.4. So this would be really, really, really simple to implement per half. A lot of the complexity would come in hardware. Or not hardware, sorry, software. So that's a Nordic. For the AT SAM 4S, oops, 8B, more of the complexity would come in with the actual MCU to Bluetooth handoff, because now it's basically the same thing, where I think you can just connect. How many GPIO are there on the Atmel chip? LQFP, this should be the 64 pin LQFP layout. Not the QFN. I swear it's 16 pins for the TQFP, or is it only 48? Am I tripping? Yeah, no, there is LQFP 64. Well, SAM 4S 8B. Yeah, okay, LQFP 64. Oh, they just didn't draw the leads. Okay. So how many GPI are there? So there's PA. From PA 0 to PA 24? 27. So that'd be 28 minus 2, 26 plus PP 14. So from PB 0. Oh, PA 31. What the hell? Okay, so 32 plus 14. Is there PB 15? No, I don't think so. So 30 plus 15 is 45. You could also just do the direct connection with the SAM chip as well. But then the question is there a Bluetooth companion chip? Bluetooth display module. What is this chip? Technical details. Matic 50 no, NRF 51822. Huh. I didn't know this existed. Just kidding. I did know this existed. But it doesn't have a USB. Yeah, okay, that's why I didn't use it. Okay, so I do think the easiest route is going to be using the Nordic chip. Unfortunately, I already have the ESP32 on hand already. Does ESP32 have USB? Ah, S2. Okay, so I don't have that. Which means that the best bet for a wired device is going to be the Atmel SAM4 SAP. The best bet for a Bluetooth device is going to be Nordic because of the power budget constraints. So I think this is probably what I'm just going to go for with this project. Just re-implementing a Nordic chip on there, even though that's like... I think I'll try to do it from scratch. Design everything myself, including the antenna layout. Maybe try to do a PCB antenna. I feel like that'd be pretty fun. Sure. Okay, cool. So for this project, at least I'll just go for this. I already have, let's see if there's a Nordic NRF 54L15. Sneezed. Should I go for the NRF 54L15 or should I go for the 52840? 840 versus 52L14. Let's see. Doubles the clock speed, improved energy efficiency, Bluetooth 6.0 and channel sounding. What is channel sounding? Oh, distance measurement. That's interesting. Hmm. Oh my goodness, this is only $40? Are you kidding me? That's crazy. Yo, we should get a couple of these for solar. Wait, that's actually insane. Nordic Power Profiler. Let's see what the Power Profiler is. PPK2 is $90. Okay. NRF 52840 average current draw is 100 microamps. Wow, that's pretty crazy. Alright, I think I know what platform I'm gonna go with then. That's definitely very cool. I want to play around with this a bit more. Alright. Alright, so let's make a note of this. Switches that I'll be using are just ones that I have on hand. I think I have a good number of switches on hand. 54L15, PMIC, Nordic, and PM1300. I've used that before. Battery, I can just get off of AliExpress. Lithium ion. Pouch, cell. And then switches will just be the ones I have on hand. And is there anything else I'm forgetting? Because I mean, if we're just going to be doing direct connection, I don't need diodes or anything. And then if we already have a power management IC, that's that. USB-C, all the other passives can just be added on afterwards. Should I have RGB? Nah. If I want it to be power efficient, I'll just not have RGB. But yeah, okay. I kind of like where this is going. I kind of like where this is heading. Cool beans. And I think for the next stream, what I'm going to do is just set up all of these parts, pull up some example schematics, and then get going on that. I think the other thing that I'll do is put in an order for the dev kits for solar, just in case we want to use them for solar, because we probably will end up using Nordic microcontrollers in one application that we have in the car, at least one. I'll also get the power profiler kit, and then with that I can also get started on developing some stuff in Zephyr. So that'd be really cool. Nice. Alrighty. I think this is good for now. And then I'll probably next stream. Let's write this down. So agenda for next stream. Agenda for next stream is get library components in Altium for all PCB parts. Nail down split keyboard layout, and then what else are we doing? What else did I say that we're gonna do? Get Zephyr. Am I forgetting anything? Maybe we can just get the schematic also. Yeah. Am I forgetting anything? To do just in general. Place order for dev kits. Place order for PPK. Actually, power profiling kit. And these are just going to come from... Oh, I closed the tab. Alright, that's fine though. Cool. The thing is, once I nail down, this is the key, which is getting the actual layout, because that's going to inform basically everything else with the design, whether it's 3D like the mechanical design, or if it's going to be the PCB layout, or where the connections are going to go and all that jazz. So I think that's the most important part that I need to work on, is to find a good layout that I actually want to use and go from there. So alrighty then. Thanks everyone for tuning in. I think I'll just call it here, and I'll see you guys tomorrow. Good night.